Welcome to NEET Direct program by SP Smart. Today we are discussing the assignment solutions from the chapters of magnetic effects of current and magnetism, day 3rd. So let us start from question first. An electron of mass m and charge q is traveling with a speed v along circular path of radius r at right angles to a uniform field b. So right angle means it is 90 degree. All right. If the speed of the electron is doubled, well, before I start the solution, let me write radius is given by mv by qb. This is a standard formula for the radius of a circular path. Okay, now call it number 1 or say this is r1. Now you have to uh, double the speed, so m into 2v. Field is halved, charge remains same but field is halved. Let the radius be r2, and this can further be written as mv by qb into 4 because this 2 will get multiplied over there. So this is r2. Now you have to find r2 by r1 is mv by qb 4 into mv by qb. These things get cancelled. It is 4. So as per the question, radius was supposed to be r, and what is the radius now? It is 4 times r1, or you can simply say the value increases 4 times. So 4r is the answer to this problem. That is option D is the correct option for question first. Now let's move on to question second. The true value of angle of dip, that is delta, is 60 degree. All right. The apparent dip, that is delta prime, is what you have to find out. Angle of inclination is 30 degree. This is the data given. Well, as we know, tan dip true is tan dip virtual into cos of alpha. This is standard formula. Now true dip is given as 60 degree, virtual you have to find out, and cos alpha is 30 degree. Now let's check out. It is tan 60 divided by cos 30. Now as you know, tan 60 is root 3 and cos of 30 is equal to root 3 by 2. These two get cancelled. It now becomes 2 because 2 goes to the numerator. So it is tan virtual dip is 2. Delta prime therefore is tan inverse 2. That is answer to this problem. So let's check out. Tan inverse 2 is option B. So B is the correct option for this problem, right? Now let's move on to question third. The time period of vibration magnetometer is T naught. Well, formula is 2 pi I by mb, and this value is given as T naught. You call it number 1. Now it's replaced by another magnet whose moment of inertia is 3 times. Well, for that, instead of I should write 3I, right? And magnetic moment is 1/3 of the initial value. That is 1/3 means m by 3, but earth field remains same. Then you have to find what's value of T. So 2 divided by 1, that is T by T naught. This 3 goes in the numerator, becomes 3I by mb, and here it is 2 pi I square root mb square root. See what cancels. This 2 pi gets cancelled, mb gets cancelled, I gets cancelled. It's root 9, and when you solve it further, it becomes 3 times T naught. So option 3 T naught. Oh well, this is option A. So answer to this problem is A. So in this way, we have solved today's assignment given to the students, and this is a complete solution. Question first has this as option, question 2 has this as correct option, Question third is this correct option. And that's all for today. God bless you all.